Hi, this is Moser with a guide to binary ionic compounds, naming and writing formulas. So, before you start this process, here's what you should know. You should know what a binary ionic compound is. So you'll know that binary refers to something that has got two options, and a binary ionic compound is an ionic compound made up of just two ions. Okay. Things like NaCl, made of sodium and chloride ions. Things like magnesium fluoride, made of magnesium and fluoride ions. Things like calcium oxide, made of calcium and oxygen ions. Okay, cool. The second thing you're going to need to know is the naming conventions for cations and anions. I'm assuming you already do. So you know that cations are simply named for the element that they are made from. So Na1+ is just called the sodium ion. Magnesium 2+ is just called the magnesium ion. Those are pretty easy, the cations. Positive feelings about cats. The anion naming conventions are slightly different in that when naming an anion, and I'm assuming that you know this, we drop the original ending of the element in question and we replace it with an IDE. So fluorine becomes the fluoride ion, bromine becomes the bromide ion, and sulfur becomes the sulfide ion. I cannot stress enough how important it is to pay attention to those IDEs. Right now that's the only thing you have to keep track of, but when we start other types of naming, you'll have to keep track of a few other suffixes. So you need to make sure that you pay attention to the IDE suffix. All right, the last thing that you need to know before you can begin learning to write formulas and names for binary ionic compounds is that formulas for ionic compounds are just ratios. I'm going to assume you know that, and now we're going to figure out how to name a compound. So that's where we're going to start off with. When given a formula, how do you write the compound name? This is by far the easier part of it. Let's put up a few examples. When you're given the formula for a binary ionic compound, the name is actually simply the ion names with the word ion dropped. So in this, we know that we always lead with the cation, both in writing the formula and in giving the name. And we know that Na is the sodium ion, so we don't write ion, but we do write sodium. And we know that Cl is the chloride ion, so we don't write ion, but we do write chloride. And that gives us the name sodium chloride. Pretty simple. All right, well, K is the potassium ion, and again, we don't write ion, but we do write potassium. And S is the sulfide ion. Again, we do not write ion, but we do write sulfide. So K2S is potassium sulfide. Try calcium bromide on your own. Pause the video. All right, Ca is the calcium ion, and Br is the bromide ion. Calcium bromide. All right, try MgO on your own. Pause the video as needed. Mg, of course, is the magnesium ion. We drop the word ion, magnesium. And O is, of course, the oxide ion. So we drop the ion, and we have magnesium oxide. An important thing to notice, it doesn't matter what the subscript is. We don't care that there are two potassiums for every one sulfide. We don't care that there are two bromines for every calcium chloride. If it is an ionic compound, we simply give the names of the ions, and that's the name of the compound: sodium chloride, potassium sulfide, calcium bromide, and magnesium oxide. Okay, now let's go the other direction. What do you do when you're given a name and you need to write a formula? Okay, so I've got 4 compound names for binary ionic compounds, because what I want to know is how do I write a formula when I'm given the compound name? Well, there are a couple steps to this, and the first one is actually simply writing the ions. You'll need a periodic table for this. Don't attempt it without. So if we look at lithium on the periodic table, it's group 1, which we know means that it forms an Li1+. It gives up 1 electron. And then if we look at the nitride ion, we see that it is group 15, so it will gain 3 electrons, forming N3 minus. Okay, once we've written our ions, that's the easiest part, now we're going to do the crisscross. So I'm going to write these down here again. I'm going to leave a space because I am going to take the magnitude of the charge and I'm going to write it down here as a subscript for each of these ions. That gives me Li3N1. But the nice part is, when we have a 1 in a subscript, we don't need to write it. So we're just going to write Li3N. And what that tells us is that for every nitride ion, we're going to have 3 lithium ions to balance out the charge. Okay, let's take on potassium chloride. So again, you'll need your periodic table, and when you look, you'll find that potassium is also group 1, also forms a 1 plus ion by giving up 1 electron to be like a noble gas. Chloride is group 17, which means it's going to gain 1 electron, and it's going to be Cl1 minus. I'm going to rewrite the elements there, the ions actually, and I'm going to take the magnitude of the charge and write it as a subscript for each one. So I get K1Cl1. What that means is that these charges balance in a 1-to-1 ratio. Again, we don't typically write 1 as a subscript, so I'm just going to write this as KCl, and that is the formula for potassium chloride. Alright, I have calcium bromide up next. So I'm going to look up calcium on my periodic table. We see that it's group 2, so it's going to form Ca2+. And bromine is group 17, so it's going to gain 1 electron to form Br1-. Just like I did before, I'm going to rewrite these with room for a subscript. I'm going to take the magnitude of the charge for each and crisscross it down here, so I have 1 and 2. Again, as I said before, we don't typically write 1s in subscripts, so I can get rid of that 1 altogether and write this as CaBr2. That's the correct formula for calcium bromide. Okay, last one. Okay, I have magnesium sulfide. So when I look magnesium up on the periodic table, I see that it's group 2. It will form a magnesium 2+ ion. And sulfide is in the same group as oxygen, group 16. So it's going to form, whoops, I thought oxygen, I wrote oxygen. It's going to form an S2-. I'll do the same thing I've done before by rewriting the symbols and then taking the magnitude of each charge and crisscrossing it to the other position. I get 2 and 2. Well, here's the nice thing. That allows me to actually simplify, and I can cancel those out. We always want to reduce these if we can. So what I'm going to end up with is just MgS, because the lowest common denominator for 2 and 2 is 1. It's going to be a 1-to-1 arrangement here. 1 magnesium ion will balance out 1 sulfide ion. So MgS is the correct formula for magnesium sulfide. Okay, just a few quick words on writing formulas, things to be careful about. When writing the formula for any kind of ionic compound, make sure that you always lead with the positive. Whether you are writing a formula from a name or writing a name from a formula, your cation is always going to come first. Sodium is your cation, it comes first in the name. Sodium is your cation, it comes first in the formula. Calcium is your cation, it comes first in the name. Calcium is your cation, it comes first in the formula. Lead with the positive. Always lead with the cation. Okay, the second thing to be cautious about. Subscripts are sub. Sub means below. Subscripts have to go below the line of the text. If you write something as a superscript, Br2, it'll be assumed to be a charge. It really doesn't mean anything, because the other thing that's true about subscripts is that they are signless. Subscripts have no sign. They're not positive or negative. They're just telling you how many of that particular atom there are. So that is wrong. This is also wrong. Do not attach a sign to your subscript. Subscripts simply tell us how many of a particular ion there are. If we look here, the subscript tells us that there are 3 lithium ions for every nitride. Here, the subscript tells us that there are 2 bromide ions for every calcium ion. That's it. So, whether you're going from a formula to a name or a name to a formula, you should now have enough information to practice writing names and formulas for binary ionic compounds. Good luck!